Hi guys. um okay, so I want my videos to be as diverse as possible. So I want to start also my series on advanced fluid mechanics. Okay. Sa advanced fluid mechanics tayo kasi alam ko you already know the basics of fluid mechanics, and I want you to understand the ideas and the concepts behind yung mga nagagamit natin sa fluid mechanics, yung mga foundation, okay? Kasi yung mga nasa fluid mechanics natin is only the derivations, okay, of the original foundations, okay, like the Reynolds transport theorem and the Navier-Stokes, and hopefully we do that. And yun, so before anything else, okay, before tayo pumunta, I want you to understand okay, sa basics ng approach of analyzing fluids. Okay, dalawa kasi yan sa fluid mechanics, advanced fluid mechanics. You look to the system or you look to the control volume. Okay, there are two approach to analyze a certain fluid. Okay, so yung pinakauna is what you call the analysis of the system. Okay, so sa ibang libro, this is called SYS, okay, in short of system. So yung analysis or approach of analyzing the fluid using the system is having a focus on the fluid particles, okay, fluid particles itself. Okay. And the other approach, okay, is the analysis of the control volume. Okay? Okay. Now, the analysis of the control volume is focusing on the region, okay, occupied by the system. Okay, it is sometimes bounded by it is always bounded by what you call the control surface, okay, or CS. Importante na alam natin to, okay, kasi ito yung dalawang approach na gagamitin natin from time to time. Okay, so yung una is we focus on the fluid particles, so we track the system as it flows out of the control volume. And now with the control volume analysis, so focus lang tayo dun sa region kung nasaan yung system, okay, bounded by the control surface. Para mas maintindihan natin, okay, I will have an example here. Suppose you have a pipe, okay, kunwari may pipe tayo. Okay. So, ito yung pipe natin. Kumusta na kayo dyan? Okay pa ba kayo? Bored na kayo? Okay. Nood ng video natin. Marami yan sa engineer ma. Okay. Sige. So, this is your pipe now. Okay. So, lagyan natin ng control volume. So, ito yung control volume ng pipe natin. Okay. Lagyan natin ng i-read natin dyan. Nag-ano na ako, class, nag-improve, di ba? Meron na akong mga iba-ibang kulay ng ballpen. Okay, may blue na dyan, di ba? Kasi may quarantine pa ako kanina, nakalabas ako. Okay. Okay. So ito. So ito yung control volume natin. Okay? Lagay natin dyan. And then ito, part of this is the control volume. Okay. Now, sa control volume, parang cylindrical siya, di ba? Tapos, etong mga dashed lines is representing the control surface. Okay, the surface area. Okay, the total surface area of the cylinder. Okay, the lateral areas and the two circles. Okay, that's the control surface. Now, yung nasa loob ng control volume, let's call that the system. Okay, and siguro yung system, let's have it as blue color. Okay, for the meantime, blue yung color. Okay, so initially at time equals 1, okay, or the initial condition, T1, syempre yung control volume nandyan pa, tama ba? And then, yung system nasa loob pa ng control volume, okay. And, at time equals 2, sometime after T1, yung mangyayari, okay, yung control volume will remain, but, okay, sa section na lang ha. Let's do the section kasi hindi ko na yun ma-drawing ng mabilis. Okay, kunwari ito ng section. After sometime, naging T2 na, ito na yung control surface natin. Okay. Ito yung control volume. And after sometime, yung control surface is, yung system, lumabas na. Lumabas sa control volume. Okay. So, after some time, okay, at T2, okay, this is the control volume. Ito yung control volume, sorry. Here, CV at T2. And this is the CS at T2. Okay. Ito, dito, ito yung CS at T1. Ito yung CV at T2. T1. See? Nandito yung system mo. At T2. Okay. So, there you go. This is the difference between analyzing the system and the control volume. System is going out and then you need to track it. Okay? This is how you analyze the system, and for control of volume, you focus only on that specific volume. Now, there are some cases na ganito, okay? The control volume is not deformable, hindi rin siya nagmo-move, tama ba? Only the system is deformable and moving. But there are also some examples wherein the control volume is, although it's not deformable, but it's moving. Say for example, in a case of a jet, di ba? Okay. Yung turbine, okay, jet turbines. Okay, syempre, converging, diverging yan. Kunwari, ganito yan. Okay. Parang hourglass lang. Okay. And then, that. Okay. So, this is your control surface. Itong surface area ng converging, diverging nozzle. And then, the control volume is the volume of this nozzle. Tama ba? Okay. And then, the system is the gas inside the nozzle. Now, at T1, okay, this is your control surface at T1. Yung volume inside, this is control volume at T2, and then the system, okay, ito, the gas inside, this is the system. Now, after some time, okay, T2, after some time, naging T2 na siya, of course, your plane is moving, so your turbine is moving, pupunta siya dyan, papunta doon, okay? But the system, kasi exhausted siya sa turbine, will go here, okay, to the right. So that's why after some time, okay, yung nozzle will be here, okay? Okay, having this control surface at time 2 and the control volume at time 2. Okay, going forward now, the system, okay, in the form of exhaust gases will be ejected from the turbine to the opposite direction. So this now become the system at time 2. Okay, good. So this is the case wherein yung control volume mo is non-deformable but moving. Okay? So, okay. And there is also another example wherein your control volume is deformable and also moving, whilst the system is deformable and moving as well. In the case of a, syempre ano pinakamadaling example? Balloon. Tama. Okay? So initially, itong balloon ko, okay? Initially, this is the control surface of the balloon. Tama ba? Okay, at T1. And the volume inside, okay, that is the control volume, T1, okay? And the system or the gas inside, okay, that's the system at T1. Now, after some time, okay, after some time, at T2, syempre, system will go out, okay, if this balloon is deflating, and the balloon will move as a result of the as a consequence of Newton's third law, action-reaction, it will be propelled forward. So, ang mangyayari, but deforming yung control volume kasi mawawala, makaka-escape yung gas, yung system. So, ito magdi-deform, liliit ng liliit. So, ito magiging maliit siya ngayon, but in a forward, okay. And meron pang matitirang system dyan sa loob, pero most of the system is already out. Okay? So, still, this is your control volume at time 2. This is yung control volume dyan. Yan is the control surface at time 2. And the system at time 2 is yung system na nakalabas and yung mga natitira pa sa loob. So, that is your system. At time 2. Okay. So, I hope you understand the difference between the analysis of constant volume, the control volume, analysis of the control volume approach, and the analysis of the system approach. Okay? Okay, see you in the next video about advanced fluid mechanics. Thank you.